Welcome back to the Explainer. Today, we're tackling a concept that essentially lets you pull off database inception. We're talking about building a query within a query to get past some pretty intense data limitations. If you've ever felt totally boxed in by a standard SQL statement, trying to figure out how to filter, calculate, and aggregate all at completely different levels at the exact same time, well, you are definitely in the right place. Let's get right into it. So, what exactly is a subquery? At its core, it's exactly what it sounds like, a query nested right inside another query. I really want you to picture this like a Matryoshka doll. You know those Russian nesting dolls? You've got an outer shell, and sitting completely hidden inside of it is a totally independent, fully functioning query. The real magic here is that the inner layer resolves first, and then it passes that crucial, perfectly filtered information right on out to the outer layer, which lets the outer query actually do its job.
To get a solid grip on this whole architecture, we're going to hit four main areas today. First, the query within a query. Second, filtering with where clauses. Third, calculating inside select statements. And finally, transforming data using from.
Okay, let's dive right into this with part one, the query within a query, and introducing nested logic.
Moving right along to number two, filtering with where clauses for targeted extractions.
All right, imagine you're working with two completely separate tables, demographics and salaries. Your mission here is to extract personal details, but only for the employees in Department 1. Let's check out the syntax structure. What we're looking at right now is the outer query shell. We want to select everything from the employee demographics table, where the employee ID is in, well, something. This actually brings up my absolute favorite way to read nested logic, the inside-out explanation technique. Just look for the parentheses. The database engine is basically acting like a detective here. It absolutely has to solve the inner mystery hidden inside those parentheses before it can do anything at all with the outer query shell.
And boom, here's that inner mystery solved. Inside the parentheses, we write out our subquery, selecting the employee ID from the employee salary table, where the department ID equals 1. So the system executes this specific chunk of code first. It scans through the salary table, finds everyone sitting in Department 1, and creates a neat little list of their exact employee IDs. Once it generates that list, it dynamically plugs those exact IDs straight back into that outer query we were just looking at. And just like that, your demographics table knows exactly who to pull.
Now listen up, because this is absolutely crucial. There's a strict syntax rule here. When you're using a subquery inside a where clause that's tied to an in operator, like we just did, we can only use one single column to return. Notice how our inner query specifically only asked for the employee ID? If you tried to get fancy and select the employee ID and, say, the salary in that inner query, your outer query is just going to break. It's asking for a simple list to match against the single column, so you literally must pass it a single column. Keep that rule tucked in your back pocket, and I promise you'll avoid the most common syntax errors out there.
Okay, let's look at number 3, calculating inside select statements and how to escape the dreaded group by trap.
I mean, have you ever tried to compare an individual row's value against the grand total average, only to watch your group by clause completely ruin all your math? It's so frustrating. Check out the limitation of standard aggregation. If you just throw in the standard average salary function and group your results, the database just spits back the average of each individual row, which is literally just their exact salary. Not helpful, right? But take a look at what happens when you switch tactics. By nesting a subquery, specifically selecting the average salary right alongside your regular column names, you force the database to calculate the average salary of the entire column, completely independently. It's a real game changer. So here is that full architecture in action. Just look at how beautifully that nested logic embeds right into the select statement. We're selecting the first name, the individual salary, and then, boom, our subquery drops right in to calculate the overall company average. Then we just finish the query off normally with our from and group by clauses. That little subquery is acting like a standalone calculator. It broadcasts its one single value, the overall company average, across every single row of your final output. You just successfully escaped the group by trap.
Moving to our final area, number 4, transforming data using from to build temporary tables.
All right, we are now officially moving way beyond just using subqueries as filters or calculators. We're going to use them to build entirely new, temporary tables right on the fly. Applying that handy inside-out rule again, let's start with the inner block. Here, we're grabbing the gender, the average age, the minimum age, the maximum age, and the count of ages all grouped up by gender.
If you ran this completely on its own, you'd get a nice little summary table with just 2 rows. But what if we want to query that specific result set? Well, we pull that off in 3 very precise steps. Step 1 is exactly what we just did. The database executes that robust inner query to generate our grouped statistics. Step 2, this is an absolute requirement. You have to give this new temporary result set a name. We're going to alias it as ag_table. Listen, if you don't give the subquery an alias in our from statement, SQL is going to throw a fit and give you an error, because it has no clue what to call this brand new data source. Once it's named, step 3 is a breeze. The outer query runs, and it treats ag_table as its primary source of truth. The whole shebang.
And this brilliantly illustrates the final architecture. Selecting the average of the maximum age is our outer shell. It's looking directly into our newly generated, properly named ag_table. Notice that little alias right there at the very end? The outer query doesn't care at all that ag_table doesn't actually exist anywhere in the hard drive's database schema. It just knows that the subquery generated a perfectly valid table structure, handed it right over, and now it can easily find the average of the maximum age column. It is so incredibly clean and honestly just super efficient.
Which brings us to a really fascinating final thought. We've seen how a query inside a query can filter targets, run its own independent calculations, and even spin up temporary tables basically out of thin air. But if an inner query can act as an entirely new table, well, nothing is actually stopping you from writing a third query inside of that, or a fourth, right? So as you go out there and start building these wild architectures, I'm going to leave you with this. If subqueries can infinitely generate new tables, how deep can your nested logic actually go before the database engine, or let's be real, your own brain, completely loses track of the data? Keep that in the back of your mind the next time you type out those parentheses. Thanks for hanging out with me on this explainer, and keep exploring your data.